Alright, so we got the top off of this thing. I contacted Fender to see if they would send me the schematics, and they sent me this nice polite note saying, "We don't do that. Hope this helps." So of course it does not help. And I mean, I understand liability and everything, but I don't know. I don't know that it hurts to give people schematics. Ashdown had no problem sending me a schematic for that Superfly. Anyway, so I do have a schematic that's floating around out there on the internet, and I don't know if it's accurate or not. I guess we'll have to do some visual checks to see if it's accurate. But it looks like all these cables are marked nicely. All these connectors are marked so that when you pull them apart, you know, it's easy to run a marker across the top of these. So I took some photos to remember where everything goes. We're going to work on getting that board out of here. I've been in this amp before years ago, I think to replace the loud noisy fan, and I don't remember what else I did. I feel like I've taken this board off before. I'm not sure. It's got all of these pressures, all these switches connected and the knobs. I have to take our time taking that off. And that'll be the next step. Just wanted to show you where I'm at on this troubleshooting. Maybe you've never seen schematics like this. Maybe this means nothing to you. Maybe you know more about it than I do. I'm certainly not an amplifier expert. Like I've said before, the majority of the stuff I have worked with as an engineer has been digital, FPGAs and stuff like that. So, but I know enough to troubleshoot this. So, right here is the input. You have this is your passive input, and this is your active input. These triangles symbolize an amplifier. So So in case you don't know, this is an amplifier, all that, but an amplifier is made up of lots of smaller amplifiers. And these symbols, each of these symbols is an amplifier of some type. Each one of them is set up a little bit differently, but each one is an amplifier, an operational amplifier. And so you take your tiny little guitar signal, which is less than a volt peak to peak, and you're in a series of stages. You're going to amplify it a little bit at a time until you are running it through some really high powered amplifiers that are on these boards and really high voltages and really high power, and that's what's going to drive your speakers. The signal that's coming from your guitar is just very weak, and in order to move a speaker, you need a lot more power. So to troubleshoot this, like I said, I had a local tech who looked at this, and he already said that he supposed that there was an IC that was bad on the input section. So I'm going to go along those same lines. I'm going to start at the beginning. I'm going to put a signal into the input, just like this is where you would plug your guitar. And what I did was a 4 kilohertz. I set up a 4 kilohertz signal. The human ear hears from 20 hertz to 20 kilohertz. So I just picked 4 kilohertz. And I set it up to be around 700 millivolts peak to peak, which is simulating a guitar signal. And we're going to bring it into this amp, and we're going to trace it through. And I've already done that, but let me show you that. So this says IC3, which is a reference designator. This 2, this 3, this 1, these represent the pins on the part. And IC3, if you take that and you look at the board, this is gonna be upside down for you guys. We're gonna look here first. This is the first place the signal goes. This is IC3. You can see with the silk screen. This is pin 1. I don't know if you can tell, but the side of this chip is chamfered. See this chamfer? That chamfer, if you look at the data sheet, so if you Google the data sheet, this indicates where that chamfer is. It tells you that pin 1 is right there, so that's how you can find your orientation for where the pins are. So it's pins 1 through 7 on this side, 8 through 14 on this side. And if we look at the schematic, we're going to make sure that we see the signal here at pin 3, which is the passive input through a capacitor, and we're going to make sure that we see the signal right there. So here's the signal that we're putting in. It's around 700 millivolts, peak to peak. That's a peak. That's a peak. This is a sine wave. This is what an audio signal would look like, a pure tone at 4 kilohertz. I should have turned the frequency measurement on here so you can see that too. Maybe I'll do that real quick. Alright, so here you got 700 millivolts peak to peak and around 4 kilohertz. That's the frequency. So what we want to do is we want to see if we can see that same signal. We're going to trace that signal through those amplifiers to see if we find where the signal disappears. So we expect to see the input signal here. We expect to see it come out here. I'm not sure what to expect. The gain on amplifiers is determined by the resistance going back to the input. The resistors on here aren't marked, their values aren't marked, and I'm not going to bother trying to measure them yet. Hopefully we'll find something obvious. But you would expect to see about the same signal here. And this here, let's see, does this VR1 variable resistor, this is your volume control on your preamp. So when you turn your knob, This is indicating a sweeper that goes through this to change the resistance. It's a variable resistor. And it's going through 10K resistor here. And so we expect to see a lesser signal here. And you can see I've already looked through these. This is what I see. So I see the signal getting all the way to here, and then this is where it disappears because pin 7 of IC2 is a DC voltage. But let's look at that on the scope. Alright, I'm going to set you up to look at the scope there while I probe, and I'll tell you where I'm probing. So we're going to look on IC3, pin 3, the very first place that signal ends up. And there's IC3, pin 3, 700 millivolts. Alright, now, out of that amp is pin 1. The output of that amplifier is 1, pin 1. And we see the same signal. So we saw the signal here, we saw the signal right here. Now we're going to look at this sweeper right here on VR1. Now if we turn that knob, so all we get is loss from that. So I'm going to turn that knob all the way up for the maximum input from the guitar. You see that same signal, so whatever you put in, you're getting out. Alright, so next it goes through that 10K resistor, and then we're going to look at IC2 pin 5. So we saw it coming out here, goes through R5. I don't expect any problems there. We're going to look right here at pin 5 on IC2. So it's lower now, it's gone through that resistance. I'm just going to turn this trigger level down so it locks onto that. So it's still the 4 kilohertz signal. I'm going to tweak this a little bit. I'm not increasing the signal, I'm just changing the settings on the oscilloscope so I can see that small signal better. You can see the peak to peaks down to 120 millivolt, 4 kilohertz. So that's what's going into IC2. Now we're going to look at pin 7, the output of IC2. That's the signal that says it's going to the EQ section, and we should see the signal there. Hey, there you go, it disappeared. Let's see. Make sure I'm on the signal. I'm going to tweak this so we can see the signal a little better. I'm not getting a good. Move my probe around a little bit. There we go. So that is a signal that's below 0. It's a negative DC voltage. It's not changing. It's not oscillating like you saw with the 4 kilohertz signal. It's sitting there, and it is, I got this set up to measure the minimum, minus 470 millivolts. So about a half volt low, and it's not changing. So that's a problem. So we saw the small signal coming in here, and now we didn't see, this is where we got the negative DC voltage. Now this should be the same signal because this should be going out to the EQ section, and all we get is the minus 500 millivolts DC. So the first thing I'm going to replace is IC2. I already got the chips, and we're going to replace that, and I'll show you that. Alright, I do want to remind you guys that this stuff is extremely dangerous. These capacitors that you see under here, they hold on to a lot of voltage. This is a huge transformer. This stuff is very dangerous. So I've got wood isolators holding this board away from everything, and I'm being very careful not to let anything get into these areas because this is a lot of dangerous power. So if you're not comfortable doing this, don't do it. Let somebody else work on it for you, because it is dangerous. Alright, so we are going to get IC2 off of here, and we're going to use the method where we just cut the pins off. If I can get my vision right. We're just going to come in from the top, clip off each of those pins. Let me try this side first. So we're going to go along these, because I don't plan to reuse this part. Notice I'm stopping at the last pin there so I don't fall off and scratch the board. So as you cut these, each successive pin behind it keeps you from digging into the board and damaging the board. And we'll leave the last one, and we'll just get that with a soldering iron. So I know this is a little bit different content, but I hope you like this too. You know, some of you may not have any electronics experience at all, but I would encourage you to, you know, take a class, or even just get on YouTube, and there's lots of good stuff out there. Just to have a general knowledge of electronics and electricity, because I mean, you can apply it when you're working on your house. You can apply it when you're working on your vehicles. Like a lot of this stuff that I'm doing here would be applicable if you wanted to dig into something on your car, like with the 6.0, for instance, that FICA module. You could get into that and take that apart, get to the circuit board level. You could start looking at signals on the oscilloscope. But in general, I think it's just a good idea to have a general knowledge about a lot of things. Why not, right? Especially when you're working on your house. All you young folks, any money you can save doing things yourself is useful. I'm just checking to see if I've gotten them all. I think I have. My sight's not all that great anymore, so I feel like I've gotten through most of them. So this one is still soldered. That one is still soldered. I wonder if I can get that one. I think I can get that one. Alright, let's hit this with some heat, see if those pins will come up. Alright, we're going to hit this with a little alcohol. Clean the area up. Alright, those are looking pretty good. So now, what we're going to do is we're going to apply solder, just a little bit of solder to one pad. And then we'll set the chip down on it. And we will solder that one pad, and that will orient it and place it in its spot, and then it's kind of easy to go get the rest, to solder the rest of the pins. Pick this one. And that's all we need. So you make sure that you can see this. Yeah, okay. So the white markings you see on here is called the silk screen of the board. And tells you the ref des, the reference designator IC2. It's got an outline of the chip, and this little notch tells you which end of the part pin 1 is on. So that means that the part points that way, and pin 1 is located right here. Alright, so I bought a few chips here to replace that. I bought 10, I think, off of eBay. I'm going to try to touch that, get rid of a little bit of that solder. There we go. That looks good. Okay. Now what I'm going to try to do is get the iron ready for that back, for that would be pin 1, 2, 3, 4, 5, 6, 7, 8, this corner right here. I'm going to get the iron ready to touch that, and then with my finger or another pair of pliers, I'm going to try to apply just a touch of down pressure just to hold it in place while that solder cools. The key is getting it placed and getting this first pin soldered, and then it's locked in place. Sometimes easier said than done. Just a little bit of down pressure. And there we go. That looks good. So now we're going to come in with flux and flux both sides. So what you want to do is you want to touch both surfaces so that the temperature comes up on both surfaces, and then you just hit it with a little bit of solder. Just like that. My apologies. One of these days I'm going to get better about filming this stuff. But hopefully you can see enough to know what I'm doing. You see, I'm not leaving the iron on there very long. All right, that looks good. All right, now I really want to take a look at all of them. So what I might do is turn and use my camera as my inspection camera. Alright, I'm going to plug it in, fire it up, see if anything changed. Alright, so this is progress for sure. So I didn't even bother looking here again. Actually, I did make sure that I saw the signal right there. I went straight here and I get the signal out, which is great. So I think I'm going to put it back together, put it on a speaker and plug a bass in and see what happens. So should you have any inkling of trying to do a little electronic repairs, I just thought I'd show you some of the stuff that I have. So you need a soldering iron of some type. This is a Harbor Freight special. Works just fine. It's got a good control. It's got a blinky light, let you know it's working. It's got a fine tip on it. That's the one I was using in the video. Nothing wrong with that. Flux. That's what I was using in the video. Ordered this off Amazon. Of course, screwdrivers get things apart. This is a solder sucker. You can use these. I did not use this in the video. Working on guitars and stuff though, if you got a pile of solder, you can heat it up, get it melted, hit that, and it'll suck it up into this thing. Picks. It's good to have a lot of picks around. Solder comes in spools. This is the braid, the desoldering braid. I did use that in the video. Comes in various widths and widths. Sorry. Let's see, a little toolkit. I ordered this too off of Amazon. Thank you very much. And it's got various tweezers, different shapes, different end types. I used this one in the video. I used the X-Acto in the video. Used some of the pointed ones in the video. It's a good little kit. Also off of Amazon, an ESD mat. Of course, I'm at home, so I don't have all the stuff that would be available to me at work. ESD strap. This thing came with a kit. This is attached, and everything goes to a ground on my power strip there. Hope you enjoyed that video. It was a little bit different content with the electronic stuff, but I like doing that type of thing, and hopefully, if nothing else, maybe it piques an interest for you to know that you can take a look at electronic things. I was thinking of, I've repaired our ice maker a number of times with a multimeter. You can buy parts for those. A lot of people just run out and buy a new refrigerator when all you got to do is just a couple little things to repair an ice maker or something like that. So we got that amplifier fixed, and you saw it was a pretty simple process. We put a signal into the front end of it, and we just traced it until it disappeared. And then that was the suspect IC. We ordered the IC off of eBay, got it in, replaced it. You saw all of that. It really wasn't that much work, and now the amplifier is working just fine. So we did it. I don't have any other electronic stuff to work on at the time being. Let's see, truck update. I'll give you a truck update. After that last video, I took it to the mechanic because all the high pressure stuff is all under warranty, so there's no need for me to mess with it. And they just worked on it. They replaced the high pressure oil pump last summer. You have no idea when this was made, so that's like 9 months ago, maybe, something like that. And so now it's got a leak in the high pressure system, and so they've got it. They'll probably have it for a while, and no need for me to work on it. So we'll show you the truck when it gets back and it's all happy again. And I think that's about it. But I hope you guys enjoyed this video. I hope you guys are blessed and have a great day, and we'll see you on the next video.